Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 12 from this paper, which I don't normally go to these papers. This is an OCR paper from the UK, I guess, and it's the A-level Maths B paper, Pure Mathematics and Mechanics, June 2022. I have chosen this question upon the request of some students. As we know, proof by contradiction is in P4, so this will be under my P4 material, under proof by contradiction. And this is, a topic which just kind of like started in, I think, 2020. So there's not that many questions on it. So a lot of students try to look for questions elsewhere from other, specifications. And here's a question that a student found and has requested for me to answer. So I'm going to do so. And this question here tells us to prove by contradiction that 3 is the only prime number which is 1 less than a square number. So prove by contradiction. What does that mean? Proof by contradiction is when you try to assume, you try to prove a statement, but you kind of prove it by way of contradicting it, by saying something the opposite, assuming the opposite of the thing that you're trying to prove, and showing that there are some holes in that argument which proves that the original statement must be true. So a simple example which has lots of holes in itself, but just to give you an idea, like for example, your parents come home on a school day early from work and they find you lying in bed. All right. And they said, oh, you didn't go to school this morning. Okay. You didn't go to school, you're lying in bed, that means you didn't go to school. Okay, you did school, all right? Otherwise you would be awake now, you wouldn't be sleeping. So you want to prove to them that you did go to school. So your objective is to prove that you did go to school. That's your objective, right? So you're going to prove this by contradiction. So you're going to say, okay, let's just say I didn't go to school. So I didn't go to school, all right? So you're starting with the statement that I did not go to school. So then you say to them, okay, let's now call the school and ask them to check the register, check the attendance. So when they check the attendance, they find that you're marked present at school, which contradicts the assumption that you made, which means the original statement is true. Okay, so that's one example. Or for example, let's say that, somebody accuses you of robbing the bank. You robbed the bank was robbed last night or yesterday, whatever. There was a bank robbery and we think that you are the main suspect. Okay, so you say, okay, now you're trying to prove that you did not rob the bank. That's your objective. Okay, your objective is to prove that you did not rob the bank. But you're going to prove this by contradiction. Now, this argument has a few holes in it, but just to give you an idea, you say, okay, let's say I robbed the bank. Okay, let's say I did rob the bank. All right, if I rob the bank, that means I would have lots of money, I'd be rich. I don't have lots of money, I'm not rich, so therefore, there's a contradiction there. That means I did not rob the bank. Okay, very kind of simple argument, again, which has holes in it, but just to give you an idea of how proof by contradiction works. If a lot of students is something like really abstract and they don't understand, how to even start this. So here we got to prove by contradiction that 3 is the only prime number which is 1 less than a square number. So of course we have to understand what prime numbers are and we have to understand what square numbers are in order to answer this question. So a prime number is a number which has exactly 2 factors, no more and no less. No more and no less. Okay, so prime numbers, for example, 2, 3, 5, 7, 9. Is that a prime number? Well, it has factors 9 and 3 and 1. You can express 9 as 1 times 9 and 3 times 3. It has 3 factors, 1, 3, and 9. So it's not a prime number. All of these can only be expressed like this: 2 times 1, 3 times 1, 5 times 1, 7 times 1. One of their factors is always 1. And there's only one other factor. Okay, here you have 9 and you have 3 and you have, sorry, not 9 times. You have 9 and 3 and 1. 1 times 9 and 3 times 3. There's 3 factors for 9. Okay, so it's not a prime number. Okay, it's not a prime number. So, and the same goes for 1. 1 only has 1 factor. 1 is like 1 times 1. It's just 1 factor. So it has to have exactly 2 factors, no more and no less. So that's a prime number. So we have to understand that first to be able to answer this question. And of course, we have to understand what square number is. It's just a number multiplied by itself, like an integer multiplied itself, like 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared, and so on. Okay, so let's start the question now. First of all, we have to assume, we're going to assume like what negates this statement. So let's assume that there is at least, I'm trying to be on my best handwriting here, at least one prime number apart from 3, or other than 3, say other than 3, other than 3, which is 1 less than a square number. A square number. Okay, so that's the first, that's a start. Okay, so let the prime number that we're talking about be P. Let the prime number be P. So that's the prime number we're looking for. And, you know, let n be an element of the real numbers, the integers. So n is an integer. Now, when n is equal to 2, okay, what's going to happen? Let's have a look. Now, a prime number, okay, can be, if we want to find 1 less than a prime number, we can say 1 less than a prime number, 1 less than a prime number can be expressed in this form then. Okay, so 1 less than a prime number, we can express it as, 1 less than a square number. 1 less than a square number we're looking for, okay, is going to be, our prime number is 1 less than a square number. So our prime number P is going to be equal to n squared minus 1. N squared minus 1 is 1 less than a square number. And that's the prime number we're looking for. Okay, so we're looking for a prime number apart from 3 where, you know, it's 1 less than a square number. And if n is a integer, then this will be 1 less than a square number. So let's take when n equals 2. When n equals 2, P is going to be equal to 2 squared minus 1, which is 3. Right? So we've shown that 3 is 1 less than a square number and it's prime. That's the one that that they've told us about, basically. Okay? We've got to now prove that there are other prime numbers. We're going to now try to prove that there are other prime numbers which are 1 less than a square number. Okay, so we can say that P equals n squared minus 1, which is basically n plus 1 times n minus 1 if you complete the square. Okay, now we've considered n equals 2. When n is greater than 2, all right, then what's going to happen here is you're going to have a number times another number which are not 1. None of them are going to be 1. For example, if n is 3. Okay, remember n is an integer only, right? So for example, when n is 3, you're going to have, let's look at the example, when n is 3, you're going to have 4 times 2. Okay, so this has more than 2 factors. Okay, this has more than 2 factors. This is the number 8. right? 8 has more than 2 factors. It has 4 and 2 and 1. 1 is also a factor of it. Okay, so you have 4 and 2 and 1, which is also a factor of 8. Okay, so therefore, this is not a prime number. Okay, and the same will be true for everything, because when n is greater than 2, then all of the factors will not all of the values, you can say, all of the values of n plus 1 and n minus 1 will be greater than 1, and the factors will include 1. Okay, so therefore, okay, the value of p, which is equal to n squared minus 1, will have more than 2 factors. Okay, for all n values greater than 2. Okay, so this contradicts our statement. Okay, the statement that we assumed, that there exists at least one prime number which is 1 less than a square number. Therefore not prime, I should say. Therefore not prime. Okay, so when n is greater than 2, every single one of the factors will have this times this and then times 1. Okay, so if 1 is not one of these, it is when n equals 3, then it will be a problem. When n equals 2, there will be a problem. When n equals 3 or 4 or 5 or 6 or any other number, you're going to have a number that's not 1 times a number that's not times a number that's not 1. Okay, and then they will have another factor of 1 as well. So they'll have more than 2 factors. Okay, so therefore it won't be a prime number. Okay, so okay, and this proves the original statement is correct, that 3 is the only prime number that is 1 less than a square number. Okay, so that's basically what you need to do to get the marks, but just try to be a bit neater than I am. Okay, so that concludes this question from the paper, from this OCR paper, and I'm going to, shall I make a playlist for this paper? I don't think I'll ever answer any more questions from it. Just in case I will, I'll make a playlist for this paper, which I'll put at the top right of the screen at the end of this video. And I'll also include a playlist here for proof by contradiction from P4 of my Edexcel International A-Level collection, which is, this is really 4. And I will also include here a link for you to subscribe to the channel if you haven't done so already. And on the top here, I will place a video which tells you how to use my channel to find what you're looking for. Thank you for watching and see you soon.